Hello community! In MedAI, we face currently some significant problems if we want to have a further specialization, a further fine-tuning. So we will look today at vision language model, the small and the medium up to 8 billion free trainable parameters. I will focus on MedAI because here we have new statistical data, new information, but the same is also true for any vision AI or any special cases where you are in a hospital or you're a doctor or wherever you are and you have a special case where you take a vision language model and you want to fine-tune it on your specific task, on your specific data. Here we encounter massive limitation. Let's talk about it and let's find out if we can find a solution. Now, to make it real clear, where are we? We have a huge pre-trained model, and it might either be a large language model or a vision language model, and this is great, and this takes, I don't know, $100,000, $1 million, $100 million, whatever you build. Then you say, hey, I have my fine-tuned data set, no? And I have my visual data, and then I have a detailed image caption describing the visual content. And I want that my VLM learns, if it sees something, it detects something here visually, it gives me here a written diagnosis. It tells me, hey, I see here a tumor over there in this position indicating something. So you want here the combination of the knowledge here, of the visual information into a textual information. And you have this on video, and you have this on simple images, and you have this on the time series here, whatever. So what we do, we create a fine-tuning data set. And then we fine-tune the model in this, and then we have a fine-tuned medical AI system, no? So where the dream is happening. Unfortunately, we have to face the truth. The dream is not happening. And you might say, hey, wait a minute, are you sure? Well, we have new empirical evidence from publications. And here, November 6th, we have here a beautiful publication from Carnegie Mellon University and Johns Hopkins University. And they talk about the medical adaptation of large language models and vision language models. And they ask, are we making progress? And if they ask you this question, you understand immediately what they're talking about. They analyze here 7 very specific medical AI large language model and 2 medical AI vision language model. Very elaborated system, commercial providers, open source providers, hospital, whatever. So very special systems, and they compare it simply to their pre-trained base models. And they say, if you have, I don't know, to pay more for these advanced models, what is the performance difference? So what they do, they have here the very general domain, LLM or VLM. They select the best prompt format, they select the best examples, and then they run some tests. And of course, they do the same here with the medical VLM and LLM. Best prompt format, best example, we optimize what we know, and then we have here our general domain and our medical domain optimized systems. Now let's have a look at the result. They present this in this way, and they say here, look, if there's a tie between the base model and the medical system, it's a tie. So you see here for an LLM, zero-shot learning, in 56% of the cases, it's a tie. There's no difference between the MedAI and the base model. In 9% of the cases here, the medical model wins. And you say, wait, just in 9% of the cases? Yeah, that's what here those universities found in their evaluation. But you know what's even more, I don't know how to say this, not so great, that the medical model loses against the base model in 34% of the cases. And you say, how is it possible that a specialized MedAI system loses against the base model in 1/3 of the test cases? Well, have a look at the other results. If we take now a vision language model with a zero-shot, the success rate of the, if you want, medical model in green, that the medical model wins, goes down from 9% to 6%. The tie increases here to 75%, so there's more or less no difference on this test set if you have an advanced MedAI system or just the base model. And the medical model loses now only, quotation mark, in about 20% of the cases, because otherwise it's a tie. Now, if we go to a 3-shot prompt optimization here, the situation changes. It does now increase the medical model wins. Now it goes up to 12%, but the medical model loses, goes up also to 38%. And for the VLM, you have a tie in more than 80% of the cases. So if you look at this here from Carnegie Mellon and Hopkins, I would say this is not a good result that we want to see. And you might ask why. And in this video 2 weeks ago, I showed you already, there are new methodologies now in the research community. I called this video the new VLM post-training layer scaling to combat here the forgetting that we have. If we have here, we use a pre-trained VLM and then fine-tune it, we have something like catastrophic forgetting. And I showed you here in this very simple explanation how we can combat this. But since this is just 2 weeks old, this research, of course, it was not implemented in the current testing, and it is not implemented in the current medical AI system. Methodology, by the way, is called LINES, and you find all the details here in this video of mine. We have recent works, 2023, on LLMs that show that fine-tuning primarily adapts the pre-existing factual knowledge for a specific task, with the majority of this knowledge being encoded during the pre-training phase. So let me be clear, what is not encoded here in structure, in complexity, in reasoning, in the pre-training phase of your LLM, you can't add it later on in the fine-tuning phase. And to make it even more clear, rather than acquiring new information, fine-tuning here, as a result of this study at MIT, typically activates and refines the pre-trained knowledge, which then remains largely stable throughout the process. So you can only fine-tune here something successfully if you only have it here massively in your pre-training data set, where you do the pre-training process to have a pre-trained large language model. And then, if you know what were the pre-trained data, the fine-tuning can be tuned here to exactly this kind of data set to have a further refinement, but not acquire new information and new knowledge. This is a massive limitation, and we know this, and we close our eyes. And I understand that some commercial companies want to sell their product. I understand this, but let's face it, this is the situation we are facing currently. And we have here a study here also from Google Research, and I already made a video on this if you want. And it tells us also, hey, fine-tuning on content which is not grounded in a model's pre-existing factual knowledge can lead to increase in hallucination. And if you want, this is the very simplified version why those models hallucinate. Because they don't find solution. And before they tell you, hey, I have no idea what I'm looking at or what I should do, they simply hallucinate because they have been trained. Generate an output, and it generates an output that is complete nonsense. So whenever you encounter, and this is also here from my video here, the fine-tuning which is not grounded in the model's pre-existing factual knowledge, your hallucination rate go up skywards. And now the main question in the community was, is it the same true for a vision language model? Or is this just a feature that we have in LLMs? And yes, you guessed it already. Google already showed us here in this publication, the same is true for a vision language model. Affecting here the multimodal models when fine-tuned on information that is not rooted in their pre-trained visual understanding. Unfortunately, we also encounter problems, and it is finally time we have to face it. Because the more we apply those vision language models, and especially the small to medium sized vision language model of up to 8 billion free trainable parameters, those models do not perform. And they do not perform here in critical medical processes. and you would wish for a system that has a 100% medical performance. So what to do? Another topic is here, the VLM model has only encountered in its pre-training low-resolution images. Sometimes it's a 1K image or a 2K image best. Hardly any training data set on 4K or 8K, and not even talking about videos. So, only encountered low-resolution images during the pre-training phase. It may struggle, yes, of course, to identify finer details, such as the drawing on a purple van or the hotel name in the background, which of course would require higher resolution images. And this would mean we need higher resolution images in our test data set and then run the complete pre-training of the model again on high-resolution images. And this would cost much more than our low-resolution pre-training methodologies. And now the question is, Google is aware of this? Also the co-author, and we read in the community here about a lot of research on this topic. So do we have solutions? And Google published here just 2 days ago, November 13, 2024, bridging now the visual gap, fine-tuning multimodal models with knowledge-adapted captions. So if you want, this is a kind of a sub-part of the problem, a subtopic that we're gonna address now here. And Google says, hey, you know what? We have here this knowledge-adapted fine-tuning of our vision language model, or in general, multimodal models. So what is this? What they are trying to achieve? And they say, hey, we have a major limitation here. So fine-tuning small to medium vision language models on very or overly complex captions may increase here the hallucination by those VLMs. And as the model is compelled to predict details it cannot accurately perceive or even understand because it is too complex for our little VLM, the resolution is not there that you have this in the visual information of the image, or whatever happened in the fine-tuning phase that is not compatible with the pre-training phase. So we are aware of this problem. But there's also a current trend, and sometimes people think if you just put more effort, then suddenly the pattern will crash and eliminate. Well, this is not the case. So currently we are focusing on creating here high-quality, descriptive, long captions to our low-resolution images. And we as humans, yeah, of course, we are better to understand what we are seeing in an image. And then we try to write highly complicated, long-sentence textual captions. And we provide those captions now to our vision language model. And we say, hey, look, you have just a low-resolution image, but this is here the maximum we can understand what is the content, so train now on this. Or even better, we ask here our huge vision language models or LLMs or AI systems to generate synthetic text, synthetic descriptive captions. So you see we're running into troubles on all fronts here. Great. Yeah, I don't have to tell you this. If you have a low resolution image and you try to put in, I don't know, an explanation of 10,000 tokens, it's not gonna help the vision language model to understand and learn more about it. Let me give you an example here from this study by Google. So here we have it, and as you can see here, this is the object. So, and the original vision language model, or a small one, said, hey, what is happening? And now we get here an explanation here. So model says, yeah, great. And so we have here a glass, a vase sitting on top of this drawer, and the vase is filled with water. The vase has a clear base and a clear neck and is filled halfway with water, and on the neck of the wine there's a small crystal bowl. The light bulb is sitting inside the white glass lampshade. So this is just a pure hallucination by our small vision language model, that it says, hey, this looks like a glass, a glass of water maybe, or whatever. Yeah? And now it gives the explanation. What I see is a glass vase sitting here filled with water, or halfway with water, and the electricity is just sitting on top of it. So, yeah, I don't have to explain anything. This is what we encounter today with vision language model. And this is the problem we have to face now. No? So what we do, or what did Google publish? Google published here, okay, says let's go to the absolute limit that our vision-sized vision language model can understand and reproduce here a dense information content that is here at the threshold that this is a correct statement and that the VLM, our medium-sized VLM, is really able to understand and provides here almost no hallucination. So find here this threshold where the VLM is producing, let's just say good, not perfect, not 100%, just good results with only a little bit of hallucination. So you want to use the systems that we have, but reduce them here to their capacity, but of course use here the maximum amount that is available. So in order to detect now the visual attributes of the image that are unknown to the VLM, but are mentioned in the image description, what they do, they simply probe here the knowledge of our little vision language model. Yeah? So we have now a huge, Gemini 2 model generating now visual questions, which can be answered by the image description, and then letting our little VLM answer those questions, and finally measure if the response by our little VLM is correct or not. How can you imagine this? Very simply, you just look here what answers are correct, what identification of the image content is correct, and we only keep this correct statement, and then we use here the image and only the correct statement, a reduced set of textual descriptions for further fine-tuning this VLM. Because now we know we are not across the threshold that the VLM does not understand anymore, but we know we are at the threshold, so we achieve the maximum benefits fine-tuning this so that no hallucination happening because the VLM is beyond its capabilities. Let's have a look at an example given here by the official study I just showed you. So we have here a simple image, and then we ask our little vision language model, describe what you see. And the vision language model comes back and says, hey, there are at least 4 ducks visible in the water. Now, I can, as a human, only see here 2, whatever, animals here in the water. So 2 against 4 ducks. So how do we handle this now? And Google said, well, it's a nice idea. And Google comes in now with a huge Gemini model and says, okay, so we take this and we decompose it into single, simple sentences. We have a real simple complexity of the semantic content, and then we just ask, hey, what of those statements is correct? So yes, 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 and then we have an evaluation, and then we find out here by the huge LLM, hey, the statement by our little vision language model, there are at least 4 ducks here. This is a contradiction. This is not true. So in order to optimize now the VLM here, those sentence, for example, there are 4 ducks, is now taken out here of this description and taken out here of the fine-tuning dataset. We only want to have the correct statements. Now, this can take quite some time. And Google says, hey, yeah, great. So we have this process here, we generate here the proposition, and we have here a beautiful, if you want, kind of an evaluation where we had calculate here the entailment, the hypothesis and everything. Yeah, but this is not really interesting. You just find out what is correct and what is not correct. And this is more or less the solution. Huh? So we have now the big brother, the huge LLM, maybe the Gemini 2, adapts now the image description here from our little vision language model simply by editing out unknown parts that are not true, that are incorrect here. And then for the medium-sized VLM fine-tuning, we only return correct, reduced textual statement that go with an image. And then we fine-tune the VLM on this reduced correct dataset, and we hope that the VLM has now a better performance. So you see, that's it. That's simple. So we just reduce the complexity of the description. We delete all the wrong statement. We try to catch up with all the hallucinated statement. And we adapt it now to the level of our smaller vision language model. Because I think it's a general understanding that smaller vision language model, let's say 8 to 13 billion free trainable parameter, they are rather flexible. They can be handled maybe locally in a hospital or maybe at a doctor or wherever it is. No? So they are so important, those smaller vision language model, but unfortunately they are hallucinating like hell. Yeah, if you want to see this process here in a little flowchart, this is it, great. And what are the insights? Now, these are my personal insights. So I think here, if we have now complex new tasks in a hospital for medical analysis, I think we have now to pre-train our next generation vision language models, since we learn here from all different sources that fine-tuning our vision language model simply fails. We have to have task-specific pre-training. This means we have to go back a step, so where really the time where we build for the very first time the very expensive process of generating our vision language model. We have to integrate the medical data if we want to have a medical AI system. You cannot fine-tune your way into a medical AI system. And then, I know this is a cost factor, but working only with low-resolution images and expecting here performance here that is amazing and identifying the simplest details, it's not going to work. We need high-resolution data sets for this task. And I think we have to have in the pre-training of our next-generation VLMs to work with high-resolution images, with high-resolution videos, with high-resolution whatever imagery. So these are my insights. And now you see, this is quite here a problem coming up to us, no? Because we thought, yeah, we just take any VLM and just fine-tune it to whatever we need. And now we really come to the conclusion it is not gonna work. And I know that there are companies and corporations out there that try to sell you their products, and they tell you, hey, this is the best model you can have. But maybe here the AI research community is doing the studies, doing the evaluation, coming now to the conclusion, hey, we do have limitations in the fine-tuning abilities. So there we have it now. We have our little 8 billion free trainable parameter vision language model, and it is corrected by the big brother like a Gemini 2. But careful. There are compatibility issues, because imagine you have here a system by Perplexity and then you use here a correction mechanism by Google. Are they compatible? Or do companies try to have an ecosystem lock-in? Open question, whatever you guess. Also, do you think that this is really the solution here to have VLMs that are not able to solve this task right from the beginning, that we always have to have dependencies on this huge LLM, on this really expensive LLM? Well, those are all open questions. And there's another open question is, those Gemini systems or any other huge system, they now operate and generate synthetic data. So those correction mechanisms that we have coming down the pipeline to our vision language model in the hospital or wherever it is some critical vision inspection methodology, are synthetic data really the optimal data? Or are we just saying, hey, this is the only data we have, therefore we have to accept whatever those huge AI systems are giving us, whatever those Gemini 2 systems are providing to us, because we do not have human data? Or do we have now a new era where suddenly companies says, hey, we need more humans, that the humans generate now the human data that our little vision language models are able to increase the performance for MedAI tasks? Questions over questions. This may also explain, you see, we have now currently a delay for the next models, the Claude 3.5 Opus, or the new OpenAI models. They are pushed out here into the future, and we only hear as a community, well, the performance is not there yet. well, the performance increase is not as huge as we would have hoped for. So you see, we are running here into limitations, and I think with this video I made it clear they are not those limitations by those companies, but they are inherent system limitations that now Google or OpenAI or Microsoft or Perplexity or whatever huge global corporation, they are simply now fighting with those inherent limitations. And you can say, okay, so we go forward with strong model dependencies between here those small vision language model and the big brother in the background. We can accept interconnected learning and we can accept this interconnected optimization, but we do have then a huge dependencies on these huge LLMs by these global corporations. And I think maybe a more beautiful way forward would be to have those VLMs model open source, that we cut here the dependencies to their huge counterparts here, and maybe we need simply new ideas. I hope I provided some new ideas to you in this video, and it would be great to see you in my next one.